Hey folks, thanks for having headphones, if you have headphones and you're able to listen to my videos here. I really appreciate it. Look, our notes are about rhombuses and squares today. We're talking about section 5. So 2.5, let's put that up at the top. 2.5 is our section. Yesterday we were talking about rectangles, right? See right here, rectangles. Today we're going to be talking about rhombuses and squares. Rhombuses and squares. So when you have a quadrilateral, you have a four-sided figure. We went from there to a parallelogram, right? Opposite sides parallel to each other. That's the definition there. And then we're going to, like I just said, discuss rhombuses and squares. But a rectangle, we said that, let's see, what do we say? Oh, it's a parallelogram with a right angle, which means that all four of the angles are going to be right angles. The diagonals are equal to each other. We said a whole bunch of stuff yesterday about rectangles. So what is off the screen here? What else do we talk about in this chapter, chapter 2? We talk about these shapes. We talk about trapezoids, and we talk about kites. Now, I don't know what's under here. It might be a kite. I'm not exactly sure what's hiding under there, but I'm not really worried. But it's a trapezoid and kite. That's what we're going to talk about over there. They're not parallelograms. So these things over here are parallelograms. Now open up the GeoGebra sketch that I put on there for you, and I want you to grab this side. I think yours looks exactly like mine. It might be a little bit like smaller or something like that, but grab the side so that you can move it around a little bit. Okay? This thing's definitely a parallelogram, isn't it? Aren't the opposite sides parallel? Look, like I could put them right on top of each other there, right? And I think I could grab this side and I could put it right on top of that one over there. So they're definitely parallel to each other. So this is definitely a parallelogram. Now what I'm going to do is I'm going to try to make it into a rectangle. So if I drag that up there, do you notice how it's snapping to the grid? I just want to make sure these are snapped to the grid, okay? Boom, that one's snapped on there. This one's snapped on there. Definitely a rectangle, right? Definitely a rectangle. Now I'm going to make it into a square. So you guys know what a square is. You just have a rectangle with all the sides equal to each other, right? So this side up here is 3, this side's 3, this one's 3. Let's make it back to a rectangle. Now it's a rectangle, right? So it's a 3 by 4 rectangle. So see how this side's not the same length as this, but I still have right angles. And then if I make it back to a square, now I've got all four sides equal. So coming down here, all four sides equal, all four angles equal. It's both a rectangle and a rhombus. So on your rhombus, to make this clear, this might be kind of an unfamiliar word, but maybe you know what this is. It's a four-sided figure that has all four sides equal to each other. But not all four angles have to be equal. So it's kind of like a square that's been, the right angles have been broken. So this is an obtuse angle, this is an acute angle, right? It's still a parallelogram though, okay? So let's make this thing into a rhombus right now. And we're just gonna eyeball it being a rhombus. We're not gonna really verify that it is a rhombus, but I'm just gonna try and break the right angles a little bit, but still try to keep whatever this length is, the same as this length, same as this length, same as that length over there, okay? So this would be probably pretty close to being a rhombus if it's not exactly a rhombus. And I could, keep exaggerating that. I'm trying to keep this side the same length as this side, And I mean, all of these things are rhombuses. Man, I hope I'm making that clear. So let's see how good I did. If I measure the length and I go, okay, that one's 3, that one's 2.86, that one is 3, and this one is 2.86. Okay, so I've got some adjusting to do, don't I? Right now it's not a rhombus. So I'm going to try, let's see, I need to make that one 3, so I'm trying to drag that out so it's 3. My eyes, you can't tell where my eyes are looking, but they're looking right there. So now I've got it as a rhombus. All of them are 3s, okay? So when we look at our notes, they're talking about diagonals, right? A lot of stuff in here about diagonals. Let me scroll down here. Diagonals, my goodness, there's so much about diagonals. So let's add some diagonals to our shape over there. So I'm going to go to segment, and I'm going to click on a vertex. I'm going to click on the opposite vertex. There's one diagonal. There's the other diagonal. Now, Let's see. Let's zoom in on this. Do you see how in the rhombus, that's a right angle right there? Do you see how in the rhombus, let me see if I can, oops, I don't want that. Hold on one sec here. See how if I drag, come on, what's this doing here? If I drag this up here, let's see if I can show you this. Right here, this angle right here, it's getting bisected. The diagonal, if the diagonal bisects the angle, and it bisects the angle up here, see, it's not bisecting that angle though. It's bisecting this angle right here. These two angles are equal. Then I definitely have a rhombus. Okay, so that's one of the trickier ones about rhombuses. Let me scroll up here and I'll show you what I'm talking about. It says, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Not both pairs, just one pair of opposite angles. And if something's a rhombus, if a parallelogram is a rhombus, then the diagonals are perpendicular to each other. So we just reviewed that, right? I just said, hey, look at these diagonals. See how they're intersecting right here at right angles? Don't those look like right angles to you? And then doesn't it look like we got an angle bisector up here? So I want you to add that to your notes right now. If you have a rhombus, then diagonals are perpendicular. If you have a rhombus, then diagonals bisect one pair of opposite angles. Okay, we're going to use those pieces of information to try to get a little bit smarter. That's our task today. We're also going to use information about a square. So let's go down here. Come on, man. The program is terrible. I'm going to have to get rid of this program. If the diagonals of a parallelogram are perpendicular, then the parallelogram's a rhombus. Well, we already knew that, right? If one diagonal of the parallelogram bisects a pair of opposite angles, then the parallelogram's a rhombus. That's what we just said at the top. If two consecutive sides of a parallelogram are congruent, then the parallelogram's a rhombus. Oh, we didn't say that. If a quadrilateral has both rectangle and a rhombus, then it's a square. Okay, so that's pretty important, right? So if it's both a rectangle and a rhombus, then it's a square. So let's see if we can make sense out of that. If I shift this thing back to being a rectangle, okay, that's what I'm going to try to do right now. Shift it back to being a rectangle. All right, so there it is. But now I'm going to make it into a square. So let's see, this side's 1, 2, 3, 4, 5, 6 long, and this one is 6 long now. 1, 2, 3, 4, 5, 6. Okay, so now it's a rhombus and a rectangle. So it definitely is a square, right? See how the diagonals are perpendicular to each other? The diagonals are equal to each other because it's a rectangle. The diagonals are bisecting the angles because of the rhombus idea, but now that it's a square, the diagonals are bisecting all the angles. So, man, I hope I'm making these properties clear. I hope you're going to be able to do the homework today. Let's look at a couple examples and see if we're doing okay here. All right. So if I zoom in on this, they're going to say something about the side lengths or the diagonals. Let's see, they're saying LM is 2x minus 9. Kn is x plus 15. So after you have the drawing down, then I want you to add the given information to the drawing. So you're going to come onto the drawing, you're going to go 2x minus 9. And then down here, you're going to go x plus 15. And you're going to say, well, what do I know about this shape? It's a rhombus. That means all the sides are equal to each other. So I'm going to set these two equal to each other. X plus 15 is equal to 2x minus 9. And then I'm going to try to solve this equation right here. Oops, I'm missing my little plus sign. And so, you subtract x from both sides. You would add 9 to both sides. I think we're going to get 24 is equal to x, right? So we found the value of x. That's what we're going to be doing on some of these homework problems today. Let's look at one more. And then I want you to try some homework. So example 2 is we've got the diagonals of a rhombus. We know the diagonals make right angles right in here, and they bisect one of the pairs of angles. It says, let's see, the measure of LMN. LMN is 75 degrees. So in your drawing, you're going to put 75. And then it says that KNP, where's KNP? There it is, right there. So this angle right here is what we're looking for. Okay, I get it. Well, let's see. I'm going to make sure I have my information down right. LMN. Well, because this thing is a rhombus, and I know that it's a parallelogram, this whole angle down here, the whole thing, is got to be supplementary to this one right up here. So it's got to be 105 degrees. 105 degrees. Okay. Now, can I tell which diagonal is bisecting the angle up there? Well, man, I don't know, but I do know that I've got a 90-degree angle here, right? And I'm going to double check. I'm looking for K and P. Yeah, I've got to find that angle right there. Okay, so this is 90 here. I think a problem like this is a little bit misleading, but I'm going to look in here and I'm going to say, it looks to me like this is the angle bisector. So this angle here is equal to this angle here. And this angle up here is equal to this angle right here. You might say, well, how do you know that, Nelson? Well, just kind of, I guess based on the way it looks, I'm going to assume that is true right there. So if that is the way it is, this one's equal to this one, then this angle right here is 37.5 because that's half of 75, right? If that's 37.5 and that's 90, let's add 90 to that. We would have 127.5. So I've used up 127.5 for those two angles. I've got how much left for this angle right here? Well, 180 minus 127.5 is going to be 52.5. So there's 52.5 right here, 52.5. That whole angle was 105, so if I take 105 minus 52.5, man, this is tricky, right? So, geez. Where are we at now? We're at, what did I just do? Oh, I'm doing this right here. That's 52.5. Oh, so this angle down here is also being bisected. Oh, okay. So that's 52.5. Hey, let's go back and look at our information about the diagonals bisecting one pair of angles. It says, rhombus, the diagonals bisect a pair of opposite angles. Bisects a pair of opposite. Let's go back and look at that real quick, okay? So we had a square here, right? Definitely bisecting all the pairs of angles. If I grab this side and I keep it as a rhombus, so all the four sides are equal, so I'm trying to make that side up there, as close to 3 as I can get it. Okay, so I might not be able to make it perfect. Oh boy, 2.96. Oh, that's pretty good. I'm going to leave it like that. Then if I go down to measure angle, and I go, okay, let's see, let's measure this little angle right here. Oh, I got to go clockwise. Sorry. Let me try again. I'm going to do measure, and I'm going to go 1, 2, 3. Okay, so that's 40.77. I'm going to go 1, 2. Oh, man. I got to go the right way. Come on, Nelson. Clockwise. 1, 2, 3. Oh, so I think that is pretty darn close, right? That angle's getting bisected. Let's do this other one right over here. So if I go angle, 1, 2, let's go all the way to this one. 3, I get 49.1. If I go 1, 2, 3, I get 49.25. Boy, you know what? When they say the diagonal bisects the angles, it means both pairs of angles, right? You see that? So then each diagonal bisects a pair of opposite angles. So right down here in that problem, we're getting a better understanding of that theorem up there when we say, oh, look, there's definitely a 90-degree angle here. This was 75. It's getting bisected, 37.5. Then this whole angle down here is 105, right? Because 75 and 105 makes 180. And then if we bisect that 105, we get 52.5. Okay, so sometimes doing the example helps us understand the theorem just a little bit better right back here, right? Hey, thanks everybody for watching my video. I hope that helps.